Unit 4A, Lesson 3. In this lesson, we're going to continue factoring. This lesson, we're going to focus on two special factoring patterns, the difference of squares, and factoring out common monomials. The first special factoring pattern is the difference of squares. So normally when we have a quadratic expression, the standard form is ax squared plus bx plus c. But sometimes depending on the quadratic we're given, it'll be in this form where we have a squared minus b squared. So we have two different terms that are squared, which is why in the name it has squares. We have two terms that are being squared, and we're subtracting, which refers to the difference. So we're subtracting two squared terms. If we have this case, we can factor it down into a plus b times a minus b. For the first example, we want to use the difference of squares pattern to factor x squared minus 16. So starting out, we're going to rewrite this expression so that we can see both values that are being squared. So we already have x squared, but then we want to rewrite 16 as some value squared. We should realize that 16 is the same as 4 squared. So now we're in that form, a squared minus b squared. Our a value is x, our b value is 4. So if we follow that pattern, we can break this down into a plus b times a minus b. So x squared minus 16 factors down into x plus 4 times x minus 4. If you switch these two terms around, that doesn't matter. You could have x minus 4 times x plus 4. That's the commutative property. To the next example, this one a little more difficult. We have 9x squared minus 64. In the previous problem, we just had to rewrite one of the terms. In this problem, we're going to have to rewrite both terms. So we want to rewrite 9x squared as some quantity being squared. Well, the square root of 9 is 3. So we can rewrite this as 3x quantity squared. Using exponent properties from earlier in the year, we would apply that squared to each of these factors inside the parentheses. So we'd have 3 squared, which is 9, x squared. Now we need to rewrite 64. 64 is the same as 8 squared. So now we're in our a squared minus b squared form. Using the difference of squares pattern, we can rewrite this as 3x plus 8 times 3x minus 8. Okay. If you wanted to check, go through the FOIL method and simplify, and you should get back to the original expression. Now to the last example using the difference of squares pattern, we have x to the 4th minus 49. So we want to rewrite x to the 4th as some quantity squared. Using exponent properties, we know we'd have to have x squared raised to the second power. If we have a power to a power, we multiply 2 times 2, gets us back to the original power of 4. And then we can rewrite 49 as 7 squared. Now putting it into our factored form, we have x squared plus 7 and x squared minus 7. At this point, we still have two quadratics as our factored form. Looking at x squared plus 7, we have a sum, so we cannot use the difference of squares pattern to break this down further. If we look at the second one, we have x squared minus 7. We do have a difference, but 7 is not a perfect square, so we're not going to break that down any further. To end the lesson, now we're going to go through factoring out common monomials, and there are some basic steps you need to follow when trying to use this process. The first one is to write the prime factorization for each term in your expression. As you get the hang of this in the process, this step is often skipped. Next, you want to determine the greatest common factor among all the terms. And then the last part is to factor or bring out that greatest common factor that you determined all the terms have. So the first example using this factoring method is going to be 2x squared minus 18x plus 4. The first thing we're going to do is take each of these terms. We have 2x squared, negative 18x, and a positive 4. We want to write the prime factorization for each of these terms. So writing the prime factorization for 2x squared, I can break that down into 2 times x. For negative 18x, I can break that down into negative 1 times 2 times 3 times 3 times x. And then for 4, that just breaks down into 2 times 2. So that's the first step, get the prime factorization. Now we want to find the greatest common factor between all of these terms. So we look at the prime factorization and determine what do they have in common. Well, I could see all of the prime factorizations have a factor of 2 in common, and then that is it for this particular problem. That is the only thing all these terms have in common. So that is going to be the term we bring out in front when factoring this particular expression. So I factor out that greatest common factor of 2, which is going to leave me with an x squared minus 9x plus 2. We take that factor of 2 out of each of the terms in our expression. To check, you could just use the distributive property. If you multiply that 2 through to each term, gets you back to the original. The reason this is going to be useful, if we take out the greatest common factor, we can more easily look at the expression we're left with to see if we can break that down further, factor it down further using methods we learned earlier in lesson 1 and lesson 2. Now to the last example in this lesson, we want to factor 3x to the fourth minus 42x cubed plus 18x squared. So we take all three of our terms, write the prime factorization for each term. Now that I have the prime factorizations for each term, I want to find the greatest common factor. Looking at the prime factorizations, I see they all have a factor of 3, and they all have 2 factors of x in common. So that is going to be what I bring out in front, factor out in front of this expression. Once I bring 3x squared out in front, I'm left with x squared minus 14x plus 6. I would look to see if I can break this down any further. In this particular problem, we cannot. Sometimes you may struggle to determine what these values are going to be inside the parentheses once we factor out that greatest common factor. Well, if I go to my prime factorization, I'm left with an x times an x, which is x squared. I'm left with negative 1 times 2, negative 2 times 7, negative 14, x. And then for the last part, we're left with 2 times 3, which is where the 6 comes from. So if you take the time to write out the prime factorization, it's a good way to help you check to make sure the values you have inside the parentheses, those terms, are correct.